Could the long-range anti-ship missile sink the Russian and Chinese navies? Let's find out. The AGM-158C LRASM, long-range anti-ship missile, is a stealthy anti-ship cruise missile developed for the United States Air Force and United States Navy by the Defense Advanced Research Projects Agency, DARPA. The LRASM was intended to pioneer more sophisticated autonomous targeting capabilities than the U.S. Navy's current Harpoon anti-ship missile, which has been in service since 1977. The Navy was authorized by the Pentagon to put the LRASM into limited production as an operational weapon in February 2014 as an urgent capability stopgap solution to address range and survivability problems with the Harpoon and to prioritize defeating enemy warships, which has been neglected since the end of the Cold War but taken on importance with the modernization of the Chinese People's Liberation Army Navy. Competitors to Lockheed Martin protested the decision to award them a contract given the circumstances of selection and competition for the missile. The Navy responded by saying Lockheed's LRASM program was limited in scope, the decision to move ahead with them was made after an initial DARPA contract award, and that it was an urgent need to face future threats. The Navy will hold a competition for the Offensive Anti-Surface Warfare (OASU/Increment 2 anti-ship missile as a follow-on to LRASM to enter service in 2024. The OASU Increment 2 competition will be completely open and start by FY 2017. It is expected the LRASM will compete against the Joint Kongsberg/Raytheon offering of the Joint Strike Missile, JSM, for air launch needs and an upgraded Raytheon Tomahawk cruise missile for surface launch needs. In August 2015, the missile was officially designated AGM-158C. Development. The program was initiated in 2009 and started along two different tracks. LRASM-A is a subsonic cruise missile based on Lockheed Martin's 500 nanometers range AGM-158 JASM-ER. Lockheed Martin was awarded initial development contracts. LRASM-B was planned to be a high-altitude supersonic missile along the lines of the Indo-Russian BrahMos, but it was cancelled in January 2012. Captive carry flight tests of LRASM sensors began in May 2012. A missile prototype was planned to fly in early 2013 and the first canister launch was intended for end 2014. On October 1, 2012, Lockheed received a contract modification to perform risk reduction enhancements in advance of the upcoming flight test of the air-launched LRASM-A version. On March 5, 2013, Lockheed received a contract to begin conducting air and surface launch tests of the LRASM. On June 3, 2013, Lockheed successfully conducted push-through tests of a simulated LRASM on the Mk-41 Vertical Launch System, VLS. 4 tests verified the LRASM can break the canister's forward cover without damaging the missile. On July 11, 2013, Lockheed reported successful completion of captive carry testing of the LRASM on a B-1B. On August 27, 2013, Lockheed conducted the first flight test of the LRASM, launched from a B-1B. Halfway to its target, the missile switched from following a planned route to autonomous guidance. It autonomously detected its moving target, a 260 feet unmanned ship out of 3 in the target area, and hit it in the desired location with an inert warhead. The purpose of the test was to stress the sensor suite, which detected all the targets and only engaged the one it was told to. 2 more flight tests were planned the year, involving different altitudes, ranges, and geometries in the target area. 2 launches from vertical launch systems were planned for summer 2014. The missile had a sensor designed by BAE Systems. The sensor is designed to enable targeted attacks within a group of enemy ships protected by sophisticated air defense systems. It autonomously located and targeted the moving surface ship. The sensor uses advanced electronic technologies to detect targets within a complex signal environment, and then calculates precise target locations for the missile control unit. On September 17, 2013, Lockheed launched an LRASM Boosted Test Vehicle, BTV, from a Mk-41 VLS canister. The company-funded tests showed the LRASM, fitted with the Mk-114 rocket motor from the RUM-139 VL ASROC, could ignite and penetrate the canister cover and perform a guided flight profile. In January 2014, Lockheed demonstrated that the LRASM could be launched from a Mk-41 VLS with only modified software to existing shipboard equipment. On November 12, 2013, an LRASM scored a direct hit on a moving naval target on its second flight test. A B-1B bomber launched the missile, which navigated using planned waypoints that it received in flight before transitioning to autonomous guidance. It used onboard sensors to select the target, descend in altitude, and successfully impact. On February 4, 2015, the LRASM conducted its third successful flight test, conducted to evaluate low-altitude performance and obstacle avoidance. Dropped from a B-1B, the missile navigated a series of planned waypoints, then detected, tracked, and avoided an object deliberately placed in the flight pattern in the final portion of the flight to demonstrate obstacle avoidance algorithms. In August 2015, the Navy began load and fit checks of an LRASM mass simulator vehicle on an FA-18 Super Hornet. Initial airworthiness flight testing of the LRASM simulator with the Super Hornet began on November 3, 2015, with the first flight occurring on 14 December, and load testing completed on January 6, 2016. In July 2016, Lockheed successfully conducted the third surface launch of the LRASM following 2 tests at the Navy's Desert Ship, firing it from the Navy's Self-Defense Test Ship, formerly the USS Paul F. Foster. Tied to a Tactical Tomahawk Weapon Control System, TTWCS, for guidance and boosted by the Mk114 motor, it flew a planned, low-altitude profile to its predetermined endpoint. While the missile is currently planned to be exclusively air-launched, future requirements for employment across several launch platforms led to investment and risk reduction for the future competition. On April 4, 2017, Lockheed announced the first successful release of the LRASM from an FA-18 Super Hornet. On July 26, 2017, Lockheed was awarded the first production award for the air-launched LRASM. Low-rate initial production Lot 1 includes 23 missiles. On July 27, 2017, Lockheed announced they had successfully conducted the first launch of an LRASM from an angled topside canister using an Mk114 booster, demonstrating the missile's ability to be used on platforms lacking vertical launch cells. On August 17, 2017, the LRASM conducted its first flight test in a production representative, tactical configuration. The missile was dropped from a B-1B Lancer, navigated through all planned waypoints, transitioned to mid-course guidance and flew toward a moving maritime target using inputs from its onboard sensor, then descended to low altitude for final approach, positively identifying and impacting the target. The weapon was successfully fired against multiple targets on December 13, 2017, by a B-1B flying over the Point Mugu Sea range. In May 2018, a second flight test, involving 2 LRASMs, was successfully completed. In December 2018, the LRASM was integrated on the USAF's B-1B bomber, reaching initial operational capability. The missile achieved early operational capability on Navy Super Hornets in November 2019. In 2020, the U.S. Navy began plans to integrate the LRASM on the Boeing P-8 Poseidon. Conclusion: the LRASM can be a very formidable weapon. There is one area where this weapon is lacking, and that is speed. Because it's subsonic, it is vulnerable to close-in weapon systems and SAM systems such as the S-300 or HQ-9. However, its stealth may help defeat those air defenses. Hope you enjoyed this edition of Shield Wall Defense. Thank you for watching.